In order to work out the overall cost of the pizza, we need to work out what the cost of the base is, which is the bigger circle, and its cost per centimeter squared, which will give us a cost for the base. And we need to then also work out the cost of the top. But how do we work out this area? Because the radius goes all the way to the edge. But what we've been given is a width, is a distance here, where the radius for the smaller circle is the radius of the whole big base minus this width. So that's a very simple subtraction into that calculator. So we can work out what the area of the small one is based on the area of the big one. Okay, so we're moving more towards what we really want to do. So let's write a cost of pizza. I'm going to just call it cost pizza. No, I'm not. I'll stick to Matthew's language. Cost of pizza. Now, what are we going to pass this function in order to do its job? Well, clearly we need the overall radius. We agree with that. Okay, so that gives us the radius of the whole base. But we also need this little difference here so we can get the radius of the smaller circle. So we need to include the width, which is that distance. Now, how is the code going to actually work inside here? How are we going to do this? Okay, so why don't we work out what the cost of the base is? The cost of the base would simply be using the cost circle function that we created. We give it the radius, right? And the centimeters cost for it is 0.01. That should give us the cost of the base. So that's nicely parceled up. If we know that this bit of code works, it's very useful for us to reuse it inside here. So now let's work out what the cost of the cheese is, or Matthew calls it the top. Okay, again, we can use our cost circle, and this is where it gets interesting. But we are not going to pass it the radius. We need to subtract from the radius the width. Because if you think about it, that little width will mean that we're only interested in the smaller circle, so we need that radius here. Not the big radius, but this smaller radius. To calculate that radius, we have to take the big radius and subtract the width. But look what we can do here. Instead of passing it the radius, we pass it the radius. Let's click in the right place. Pass it the radius, and we subtract the width to give us the radius of the inner circle. And what's the cost per individual? I believe that's the value that Matthew has there. So now we have, in our cost of pizza, we've built a function from other functions. And inside the cost of circle, it works out what the area is for us. And there's your area function. So we end up with these really interesting layers of code. We've got a basic function called area of circle. We've got another function which uses the area of circle called cost of the circle. We then use those cost of the circle to work out what these two costs are. We have broken the problem into quite logical pieces. And so what we're going to give back, we're going to not print it, because remember, functions we want to return, we simply add the cost of the base and the cost of cheese. Now, if you're finding this video more complicated, go back and look at Matthew's lecture notes. He approaches this, he breaks the problem down slightly differently. What my purpose of breaking the problem down in this way is to try to show you that this strategy, let's get this one out of the way for the time being, and that's a decision you can make, by creating useful little functions which build upon each other and do general things for us, we get to a point where when we come to writing the cost of pizza, what happens if we had cost of 20 pizzas, or cost of, and we had whole kinds of values we needed to calculate, right? Building up a program, a function from smaller functions which themselves use other functions, has an incredible power in terms of reusing code. This area of a circle is a generic piece of code I can reuse anytime I need to calculate the area. This cost circle, because I give it the value and the radius, is also quite general. So this is my program, the cost of pizza, and I give it just these two values. Internally, it has their custom values, and that is the simplest way of building up a bigger program from a smaller one. Now, Matthew doesn't break it up as much as I have. And it's a discussion for yourself to think and code it the way he has in the lecture notes and code it versus this. So let's run it. And to run it, let's take the cost of pizza inside our print statement, open a bracket up there and say the radius is 10. I'd like to have a figure that he uses in order for us to do it. He also interestingly uses a print statement, which we will do. So let's do it in closer to the way that Matthew has done here, so I can introduce one last concept. Okay, so what Matthew asks you to do is give you input into your program. Using the input of these two values, he will work out the solution. Right, so let's do the same thing. So let's get our base radius, and we ask integer, and we've got an input statement, and in here let's make sure we say something like pizza base radius. That's what I'm asking for here, and that will give me the result in my main program. That's my first input. The second one is the cheese. No, actually what we're going to do is the crust, which is the edge of the width. Let's just draw the picture again very quickly. That's the crust, that little thin little element round there. So that width of the crust is the other input value. That might strike you as a bit of a so we put here width of crust here as our second input. Okay, so we've got the base radius of the pizza and we've got the cost. So there are our two input values. So when we're building our main program up, that's the first thing we do. The second is the actual process. And what we're going to do is put the cost of a pizza, that value is going to store when we execute. Let's just get the name. Now you might at this stage start saying, hang on, these names are starting to look like each other. So I want to pass it the radius, which is the base input, and I want it to pass the width, which is the input value called crust. Okay, so if you remember from one of the very early programs, a program is often made up of an input statement. They're the two values. They're passed into my function, which should only calculate the cost and give me back the result. So if I put, I don't know, let's just change this to overall cost. Okay, just to differentiate the value coming back from the cost of pizza. And then the final statement is a print statement. Now I'm going to replicate what Matthew has here because he's using the formatting statement. So let's just pop this into here. Let's use 2 decimal places, close that bracket and close the speech mark, hit the dot, press format, and then into that format statement we put the value we get back from there. Let's run and test it. Now if there are errors, let's see if we can solve them as we go along. So the first set of errors would be if I've typed anything incorrectly. Okay, it's happy with that. Nothing so far. I run main. What's the base radius? Let's say 10. What's the width of the crust? Let's say 1. And there is an error in here because I can see I've put a comma in here rather than a full stop. Bear with me a second. So that's the first error. So let's run the file of script again and test it out. Now what I can be confident of is as I run through this code, if I've tested all the other functions, so if the base radius is 10, the width of the crust is 1, oh, I've also got another error in here. I've got a semicolon when actually what I should have here is a colon. So notice it is telling me the line that I've got the error. Pay attention to it. I've got a key error, so let's tidy that up. It's very, very important you start spotting what type of errors you have. And generally, as you can see from this example, they are typos. So we've got 10, we've got 1, and it says the cost is $9.50. Right, we need to check independently of that value and whether that's correct. But as I conclude this rather longer video, it's a very crucial video. You will benefit enormously if you take on board a couple of handful of concepts. So let's just summarize what's been really key here for you. Putting aside the actual example, the first thing is to create functions that are reusable. So in this example, I created an area of a circle function, and the reason it's reusable is I pass it the value and it has a return. It has no print statement inside it, which means in theory I could use this code in a web page. If I could hook this as the back end to a front end, I could use it in a number of different front ends. It doesn't require me to always use the Python console. So that makes this function reusable, and that's a crucial concept. It's general, and that's the other advantage. So the area of the circle is a very general one. The next one, which is more specific, because it's a concept related to the problem we're dealing with, is called cost of circle. I pass it two values, as you can see over here, a radius and a centimeter squared. I calculate the area using the area of circle, and then I take my second parameter and I return the result of those two multiplied together. So this is again a general piece of code, but it's specifically related to the problem at hand, because the cost centimeter squared times the area is a calculation which is related to this context. So now I have two functions. When I come to then working out the cost of pizza and I pass it these two values, I can use my cost of circle, which internally uses the other one, and I return the sum of those two parts. So when I come down to my program itself down here, I ask for my two input values, then I calculate the overall cost based on that, and then I have an output statement. So input, process, output. And the advantage of you thinking and trying to solve your problems in this way is a huge advantage. This video is trickier than the one that Matthew supplies in his lecture notes. So if you find more difficult to follow, go back to the lecture notes that these correspond to and follow Matthew's simpler approach. But this takes you a step forward.